Alright, so welcome. This is the Algebra EOC Day 4 review. You all know that we spent the first 3 days working on, the first thing that we worked on were the transformations of functions. So, on the transformations of functions, just a quick recap. F of x plus 3 means that you are going to translate that graph 3 units to the left. When it's on the inside, it goes in the opposite direction. Put this up, put that up. Please put your cell phones away. If it is f of x minus 3 on the inside of the parentheses, then you are going to move 3 into the positive direction. F of x plus 3 moves the graph up. F of x minus 3 moves the graph down. Notice that this is on the outside. On the inside, it's the opposite direction. Alright. 3 times the f of x means that the graph is going to be narrower because you are rising 3 units and only running 1 unit. So that curve will be steep. But if it's 1/3 f of x, then you rise 1 and you run 3, and that graph is going to be a little bit wider. Those were the transformations that we talked about last week. Opposite directions on the inside, up and down on the outside, wide and narrow in the front. All of these will change the vertex except, I think, wide and narrow. Well, wide and narrow will change the vertex too. If it's... Alright, any questions on that? Oh, the dolphin. Alright, so the dolphin started 6 meters under the water. After 2 seconds, he got to the top of the water. At 4 seconds, he was 2 meters above the water. And then at 6 seconds, he decided to go back down into the water. This was the dolphin. If this was a graph with just a quadratic function on it with no context, the domain values are going to keep going forever and ever and ever in both directions. So when it comes to the characteristics of this graph, the domain values, which is the x, because this is continuing to go in both directions, is going to be all real numbers. The range, which are the y values, so domain is left and right, range is up and down. Range is going from negative infinity, and it's going to top off at 2 meters because that's as high as this graph goes. So the range is going to be negative infinity to positive 2 with a bracket because that 2 is included. Now y'all know we can't talk about the characteristics of the functions without talking about the end behaviors of the graph. So the end behaviors of this graph, as x approaches positive infinity this way, y, which I'm going to write as f of x, is approaching negative infinity this way. And then in the other direction, as x is approaching negative infinity, f of x is approaching negative infinity because it's headed in a downward. Alright, we're going to use this today when we talk about exponential functions. Let's hope that I can explain exponential functions in a very efficient manner. I have been making some mistakes today, and I think I have it all figured out. So, here are the things that we need to learn today, and we are not going to use any more than the rest of this half of the paper. I guarantee. Okay, so for exponential functions, what we need to answer is my other spiral. Oh, that ain't mine. No, this is not mine. I don't know who that is. Okay, here's the essential question. How do we solve real-life problems involving exponential equations and describe the solutions in terms of the situation? How do we solve? Huh? Okay. Good. All right, how do we solve real life problems involving, I'm going to put y'all out again. You want to go sit? Involving exponential functions. So how do we solve real life problems involving exponential functions and describe situations, and describe the solutions? In context of the situation. All right. I think that's the question. We are going to solve real-life problems involving exponential functions and describe the solution in context of the situation. All right. Exponential functions are y equals a times b to the x. A is the initial value. B is the growth factor. I usually say it's the growth rate, but I don't want to be like using the wrong terms. So here it is. Y equals a times b to the x. A is the initial value. B is the growth factor. The rate is the amount of change. We'll talk about that later. All right, one problem for this, and we're going to go practice with it. Oh, that was a student, and his mom gave him $500 and he's going to grow it, is it 20% every hour, I think. So here's the example. The initial investment is $500, and it is going to appreciate 20% per hour. How much will there be after 5 hours? Question mark. This is a real life problem. It involves an exponential function because of that rate that it is growing, because of that factor, and we're going to describe the solution in context. Here's the equation. Y equals A times B to the X. If you get lost on the EOC, you can open that formula sheet and you'll find exponential functions right here. Today we're going to see this one, and we're also going to see the compound interest. Alright? Oh, don't forget, if the growth rate is greater than 1, then that is growth, it is increase, and it is appreciation. If this B is less than 1, then that is decay, which is a decrease and depreciation. The equation is Y equals 500 times, if something is going to grow at a rate of 20%, then the growth factor is 1.2 raised to the x power. You're going to go to Desmos and you're going to type this equation in. Then you're going to press settings and table. Once you get the table, you're going to key in the number 5, and you're going to tell me what the output will be for 5 hours later. Give you a minute to do that. So make sure Y equals 500, 1.2 raised to the x. Then you press settings, table, and key in 5. And like she said, 1244.16. So look, make sure that you can describe the solution in the context of the situation. That means that f of 5 equals 1244.16. So after 5 hours, the amount is $1,244.16. That is some major growth. Alright, I'm going to leave this up for a minute and I'm going to give you some further directions.